Afternoon, everybody. How are we all doing? How are we all doing? Live at the normal time today. I nearly did do a 4 o'clocker because it is nice here at the moment. I was thinking maybe we would sit out for a bit longer today, but Mrs. Cruncher's got other ideas, so it's a normal start. So we got a few in already, quite a few in actually. We got Tim in. Tim, Aaron, overcast. Well, it's nice here, but there is a fair bit of cloud about, Aaron, so it's sort of on and off. Afternoon, Chris Milky. Joe, how are you? Matamali. Tom and Susie. Rob Tiveridge, Rob. Bob Anderson, welcome back from your holes, Bob. Derek's down in Bude. That's only about half an hour, 40 minutes from me, Derek. Afternoon, Bob. I just say hello, Bob, already. Cracking up. As always, Martin's in. Hello, Martin. We'll be here the first few minutes, then have to do stuff. Tinu S. Welcome, mate. Benji's in. Just getting your medication. Afternoon, Multi. David Tipton. Hi, David. How are you? Gavin's in. Hi, Gavin. Electrosound. A chili Ballarat. She bought a Hacker Super Sovereign for $20. RP 76 MB, 75 MB maybe? Is it 76 MB? It's 75, isn't it, I think? But very nice radio electrosound. Very nice. I've got a flashing battery light on this. I'm still on the batteries that I put in last week, the Panasonics, so they will go at some stage, but I've got a couple ready to go in. So I'll try and keep an eye on my little green thing and make sure it's still on. I said hello to Gavin, didn't I? Hi, Gia, how are you? The sunny Arctic. Danish. Hi, Paul. John Hurd. Hi, John. You had computer problems, John, did you? We're all right, mate. Thank you. Dave Rhodes. Hi, Dave. You're going to try and join in any capacitor bingo. I think we might have a bit of capacitor bingo because Chris is after this radio and he wants it recapped. You got a manual as well, Electrosound. Wow. Aaron loves capacitor bingo. I don't know what it is about it. It's addictive, isn't it? We're certainly going to have a bit today. So we've got something on the bench waiting for insertion. We've got something waiting to go in. Hi, Gerald, how are you? You think it's a tired electrolytic elsewhere in the set as well as needing a bit of realigning? Not as good as many hackers. No, you're dead right, mate. Switches could be culprits. We did give them a squirt, didn't we, last week? Sometimes, though, it does take a bit of time for the switch cleaners to actually work. So you never know. I do love a bit of finger, Dave. I do love a bit. Let's get one in anyway. Because I am a bit thirsty. It's not overly warm here today. There's a bit of a breeze going. I think it says the highs of 15, which is pretty good. Don't get me wrong, it's better than it has been. Saying that, we've had some nice days actually, haven't we? So there we go. Cheers, everybody. The alcohol on the finger is If it focus, will you focus? 5.2. 5.2, Joe. Any news on the AC127 as long as it's in a metal can? No, I did say, Benji, I did have a look and I haven't got anything. Nothing came up in the hoovering. Nothing came up in the hoovering of the floor. I'm just trying to think how to get you one. I must have some boxes of bits I've pulled out of other radios that I've changed transistors on. You'll have to try and remind me, Benji. You'll have to drop me an email just to remind me. 15 degrees top temperature is good. Ah. Ouzo, very nice. You've been to Greece, Bob, have you? God, I do love a drop of ouzo, actually. I do like a drop of ouzo. I don't drink it with water, though. I don't mind it with water, but I prefer it on its own. It goes cloudy if you put water with it, doesn't it? Not that I'm no expert on ouzo, but I have had a fair drop of it before. No finger for you then, Jer. Yeah, I think it was Anthony that suggested that you use a capacitive dropper system to get it down to 110. You've used this later smaller transistors as you enclose them in a roll of copper sheet, and once in a heat sink they look virtually the same. That's a good idea, Gerard, actually. Yeah, if you will, if you will. Afternoon FM, 21 degrees, very nice. Sun has just come out, nice, nice. Right, well, those of you that watched along last week or caught up with it, the radio was sort of working, wasn't it? I think AM was okay, but FM seemed very deaf. From memory, that is. My memory's not great, but I think that's where we were with it. Which is why I decided to pull the module out. And I think it was Gerard. Gerard or Jed? Gerard that said it was probably going to be the later version of the module, which indeed it was, with the AF125s in it. Good afternoon to you, Murat. How are you, mate? Did you make a ginger beer? I do like a drop of ginger beer, Aaron. I did look up these radios on eBay the other day as well, just to get some sort of idea as to value. Ought to say hello to this boy though, don't we? We all know who this is, don't we? We do all know who this is. Frankie! He's here. He's in the house. This is my modular set. I do need to do something with Frankie though, because FM doesn't sound great in him, because he's got a poorly FM module, but it does work. So the idea today to start with, before I do anything else, is to connect this setup to the module, and then see if it works attached to Frankie. Let's zoom you out a little bit. Maybe too far. You ever serviced a vintage tube radio that used unusual valves? I serviced one of those little tiny Marconi, was it Marconi? Little tiny clamshell one. I think I did that for Tony. Was it Tony? So yeah, the idea is to get the module, which is, where's the module? Over here. Which is an LP1164-1, and it's got 02 written on it, which apparently means it's the later module, if you can see that. So 1164-102, that's the clue, apparently. I've got quite a lot of these radios here. I pick them up when they're cheap because I know I can fix them, and 9 times out of 10 they don't work. This one definitely looks like it's been worked on before, because that's not the original module. Someone's put another module in it, so it's probably been back to the factory. To say, this has got the little smaller AF125s in it. You see those 3 transistors? There, there, and there. And the module hasn't been reworked, it's had another module put in it. Because I don't know about the serial number, but it's not new enough, I don't think, to have the newer module in it. I might be wrong, but the newer ones, they were a little bit different. Anyway, I think, have I all got the whole finger in now? Yeah, I have. I've got the whole finger in, so cheers again. Let's get that out of the way then. Zoom back out. I've got room to move in here now, at long last. I've got rid of that big old Marconi signal generator. I actually gave it away, believe it or not, to someone on the local free cycle. Free cycle is the last resort when you just got to get rid of something because it's just too much. Right, so I've got me book, because I need to know which wires do which. I mean, I really ought to do this a bit better. I ought to bring these out to some sort of module. I was looking at ZIF sockets, but I don't think they'll be any good for this purpose. So somewhere in here I've got a little picture with all my different modules in it. Here we go, R707. Check AFC operation. Yeah, made that mistake once. Right. Let's hook her up then. So I'm gonna make sure I get this the right way round. So we've got 1, 2, 3. Yeah, okay, so this side here we need red at the top. And yellow. I hope, anyway. He'd go bang if it's not. If it's not, we will need a new module then. Blue. And the negative. It's one side connected. Now this side then. There's a signal in. I'm not convinced this is the right way up, you know. See, what I failed to do in this diagram, because they got pins that aren't used on these, you see. Pins that do nothing, and this one's got less pins than some of the other ones, actually. Let me just double check this a minute. So I have got here somewhere, hopefully. The computer's making lots of whirring noises today. Maybe I'm dusted up again. Was it LP1164? So where are we? Screen cap made. So let me just have a look at this a minute. Just make sure I am the right way round. So 23 and 24, yeah. 11, 12, 13. Yeah, I was right. I always like to date myself, don't I? So this is a picture of the module with the AF116s in, and for all of those that are interested, that's the circuit for it. So you can see you've got two rows of IF transformers. One is AM and one is FM. So AM and FM goes through all of these transistors. What you do find sometimes, though, is that one will work and the other won't. And that's usually a transistor problem, because what tends to happen is sometimes for whatever reason, it'll either pass an FM signal and not an AM signal, or the other way around. So I mean, that's my thinking in this, that our AM seems to be working all right, but FM is really quiet. So I'm thinking one of these has gone a little bit pear-shaped, possibly. Or it could be some of these electrolytics. Because there is 5 electrolytics in this thing. So it could be one of those that's leaking FM away. Done by Ron Bryan. Very brilliant. Good kit, 2008, look, version 1. I wonder if you ever did another version. It would be nice to have a signal path where it all goes through, and be able to sort of like click on the signal path and know what a lot of these components do. I mean, to me, D4 and D3 look like the FM discriminator. There's D1, the AM detector, possibly not. It might be D2's the AM detector. Yeah. I'll say these are all IF transistors. Right, so we did get it right. I was right, but you know, you got to date yourself sometimes. Jess, how you doing, mate? Afternoon, Derek, Duffman. a Philips D8444 that you can't get fixed, Murat. Why? What's wrong with that? Doesn't recognise it. Yeah, I didn't notice that. 3 labels on top of each other. You bought it in August 2024. That's a brand new one. That's newer than that's actually, you bought that in the future, Derek. You bought it in the future, mate. Oh dear. Afternoon, Anthony. How are you, mate? Right. So I was right, but you know, you do date yourself sometimes, and these pins are a bit of a pain. I really could make this a bit easier for myself, couldn't I, with a few modifications, but it's always worked, this. And sometimes you just don't like to touch something that is going well, do you? It's always worked, this. It's one of the best things I did, this and the one for the R600s. It makes life a lot easier. Also allows you to adjust them on the fly as well if you think that something's not right and you want to give it a tweak. It's much easier. I wouldn't recommend touching any of the cores in these, people. Do not twiddle. And goes there. And we've got our ground. Yeah, I have got some more probes to make these clip-on ones a bit easier as well. But yeah, I thought maybe a ZIF socket or something like that, but then it'd be really hard to wire it up because these pins are random. There's no sort of size to them or anything like that. Right, so it's a 12-volt set, so let me get my power supply sorted for 12 volts, which is on anyway. Set the current down low just in case. Pop it in. Area up. FM. Try, see if we can get something on AM. So AM works fine, but FM, It's distorted and very quiet. I mean, that's classic FM there. Just not right. No, nothing's been changed yet, Anthony. Oh, it was changed in 2001 by Roberts, Derek, or by yourself? Afternoon, Les. Cloudy and miserable, Howard, is it? Did it play Doctor Who music? I don't think so. It might do it if we really ask it. I think we're going to run out of batteries any minute. Let me just change my batteries a minute because that the battery indicator is completely gone off. So bear with me a sec. Yeah, we should be back. Yeah, not worth running out. Zinc chloride. So, I mean, it's just using them up, wasn't it? Pointless having batteries if you're not going to use them. It's look darker in here today for some reason. I think maybe I've darkened the camera down for some reason. John Wilson. I don't know John Wilson. Push button dial lamp. Yeah, it's a good idea if you want to play about with that. Right, let's just have a look at that circuit again. Because it may be that someone's just twiddled this, because sometimes if you've got a problem with one of these, it can make a dramatic difference. So I think it's the yellow ones that are FM. So we're looking at T1, T3, T5, T7, is that right? Yeah, so FM second, so what we don't want to touch is, well, someone may have touched that one, T10, which is a yellow discriminator coded black and blue. That's this one. So T8 backwards. Yeah, so all the others are IF transformers. So the only one we've got to be really careful with is T10 and not to mess with that one. So let's give them a little tiny move, a little tiny tweak, and see if it makes any difference. And I don't recommend you ever doing this, so close your eyes. Unless you've got the kit to do it, then really this should be on a signal generator with it all hooked up to all sorts of things and swept generators and all that sort of stuff. But it ain't. This is just to see if someone has actually tweaked it. Someone's got in there and had a play. Let's have a look which one fits these. I want a nice tight fit. They're plastic headed ferrites. So you can't break these, which is one good thing. He's just throwing his stuff all over the floor. Yeah, that one fits. Right. Right, let's turn it on then. Hello? Ah. Our grounder's come off, that's why. I thought something else had gone wrong then. All I've done is try the tool in it to make sure it was going to fit the trimmer. So I'm just going to give that discriminator a little.
I've got it. I haven't got it.
No.
Optical coherence tomography, an advanced eye health scan that can help spot sight lesions early. At Specsavers, we think it's so important we're providing it nationwide.
Octopus coherence. I've got the giggles now.
Not everyone can say it, but everyone can have it. Add it to your eye test for an additional charge. Check your local store for availability and price.
Summer mornings on Classic FM.
Wake up with Dan Walker.
I do hope you're having a fantastic Sunday. I'll be back tomorrow.
That is better.
Goes off. Try this. Don't reach for the snooze button. Just switch on Classic FM Breakfast. We are playing even more brilliant music for you all throughout the summer, so you can wake up the day and the week in the best way possible. Classic FM Breakfast with Dan Walker.
Listen on your radio and on player.
Tomorrow from 6:30. Classic FM.
No, it's still not right. So we need to have a look at the module. Anybody got any anything they want me to try before I start pulling the module apart? Unfortunately, I've got no voltage measurements for any of this. We do know that there's a couple Mullard caps that need changing that have got damp, so they've got to be done. Whether they're in the FM section or the AM section, I don't know. GT Jeff, how you doing, Jeff? The overall is you have to align the IF and RF transformer with the insulated screwdrivers because the case is hot. Yeah. So does it look like it's an alignment issue anyway? I have brought it up a little bit by tweaking it. But there is no voltage measurements on those charts. It would be useful, wouldn't it, to get a fully working module, a fully zapped one. Let's go back to this. So let me see which two caps are dodgy. So that one there is dodgy, which is this one here. So C5 is dodgy. That's got the ends broken off of it. And the other one that's dodgy is C6. So C5 and C6 are the two that have got pieces broken off of them. So let's just see if we can see, let me think. So it's the 1, 3, 5. So it's the odd number ones. So what did I say? I've forgotten again already. C5 and C6. So there's C5 and T4 is AM. Where's C6? C6 is on that transistor. That might, I suppose, that might affect the frequency capabilities of that transistor, maybe, if that one was faulty. That one is just connected to the positive. That would affect the voltage going in there, I suppose, on the secondary of T3, but then it would affect T4 as well, but maybe... So yeah, C5 and C6 could throw it out. So I think it might be worth changing those two first and see how we go. So what are they? 47 NF. So let's find a couple 47 NFs and get those two swapped out. We've got these other caps to do. Again, are the electrolytics anything specific to FM? I mean, that one there, that looks like it's on the AM side, some sort of feedback. This one's on the FM, look. Yeah, this one may be on the FM, C19. It says AFC out. But it is connected to, this is the discriminator diodes. And C16 is definitely, so C16 I think is, and C18. So 16, 18 and 19 are all to do with FM really. Although by the looks of it, FM out is coming off of this section. So 16 and 18 are the two most likely culprits as far as that goes. So 18 is this one. And 16 is this one. So these two here. So these two here and these two. So what we'll do is we'll change these two first, see if it makes any difference. Then we'll change these two and see if it makes any difference. So this is the beauty of having Frankie really, because it allows you to do this and test it. Whereas in normal practice you'd have to refit it, then take it apart again, then refit it and take it apart. It's a nightmare. So this should sort it right out. You expect to see a working radio is plus 7%. Excellent. Yeah, it's just they're these poly type caps and they come rated pretty high. So 47 NF, wouldn't it? 47 NF. 47 NF, and that in normal money is 0.047 UF. 47 NF. It says I've got 47 NFs in here. Let's have a look at what we've got. No, they're not going to fit. So I'm going to have to go to my non-polarized caps up here. We must have got 47 NFs, Graham, surely. Yeah, there we go. Yeah. Not a lot though, looks like I've used a load of those. I've only got these left, these blueies. 400 volts, these are rated at. Oh. I would have thought I'd have had some there. 82.47. 0.15. No, looks like they're the only two that I've got then. So, a couple, as I say, a couple of blueies. 400 rated. Let's get a desoldering tool sorted out. I thought I had some of these like brownie coloured, like these ones. I thought I had some of these. But obviously I haven't, so I'm going to have to put an order in for some 47 NFs. I have got some other 47 NFs. Oh, hang on. No, tell a lie. I've got some smaller. I thought I did have some Nichicons, look. Oh. Hidden in underneath the poly one. So I have got a couple of those. 250 volt rated. But I do need to get some more of those. So I need to make a note of that. Someone remind me, I need a bit of paper really. I've got loads of paper, but I don't want to rip a page out of my book, so I use that quite a lot. No, that's all invoices. I'll write it on my phone. So, 47 NF poly. There. Done. So I'll pop these out with it still all hooked up. I've got everything turned off. I'll pull that just in case. But, it won't hurt to keep it done like that. Just going to quickly nip to the loo a minute while that's heating up, and I'll zoom you in on the module. I'm just waiting for the desoldering gun to heat. It does take a little while, that, doesn't it? Right, I'll be back. Still sunny out there. There is one other thing that it could be that I didn't mention. It's one of those discriminator diodes. Now I've had a hacker set in the past. In fact, it was a hacker hunter. They're distorted FM and pretty quiet. And it was actually one that Sean had, I believe. And he sent it out to me. It took me a while to work it out, but it was one of the detector diodes had gone. So there are stranger things that can happen. Right. Let's get desoldering then. Let's whip these two out. So it looks like there. Got to be in and out pretty sharpish with these boards because they are really dodgy. Now, have I got the right one? Is that one? Yeah, it looks like it. Okay, that's that one. And the other one sort of squeezed over here. So I think it's that one. And that one. Right, I'm going to get my eyes on now because you've got to be really careful with these boards. I need my little tiny screwdriver. Now, what have I done with that? There he is. That's that one out. This one. Yeah, that one's loose, but this one isn't quite. Right, there we go. Massive great soldering on tip on there. So there's our two caps. He says, where's the other one gone there? Ah, one's got a leg dropped off, look. So that could be the issue. Now that was the long one going there. No, it wasn't. Yes, it was. It was the long ways one, so it was. Let me just have a look, see which one it was. It was C6. The legs dropped off of C6. C6 or C6? C6. And that is the one that's on the emitter of VT2 or TR2. Interesting. So you gently pop that one out. So I can't even test that one. Well, I could test it. Just got to push it against there. So we could test those. Well, should we do some capacitor bingo? 47 NF. Let's just pop these in. Solder on that now. Again, making sure we're not going to push any tracks, and we might do with that one. Now this one we're going to have to do a bit of fashionable leg bending. Do not bend these once they're in, because you will break that board. The traces on these things are so tiny. Right, just change soldering iron tips a minute. I'm going with a fairly fine tip now, get rid of that monster. I think he's falling over here. Whew. So that someone's hammering stakes in out here. Stop now. Someone was staking vampires, I think. Right, let's solder these two up then. It's a bit warm to wear the old magnifying glasses at the moment, but you know, you've got to be done. Yeah, they are 0.047, Timothy. 47 NF. I looked that up on my little chart, 0.047. Seem to have a bit of a soldering or entangle up situation going on here. Again, you've got to be in and out of these pretty sharpish. I think maybe I just touched that one there. Right. What do we think then? Has that cured it? Has that capacitor change done the job, do you think? Let's test the caps. So I'll see if I can get a reading off of this one with the old peak. Right. Let's have some of the prop that up. Let's use one of Sean's little blocky things. See if he'll measure this one. 42 NF. Should be 47, so that's not a massive difference. Let's try this one. The hell is that banging? 51. What is that banging? Dogs aren't happy with it. I don't know. Dogs weren't happy with that. They've got to do it on a Sunday, haven't they? So yeah, I mean, it depends whether that leg was actually off of that or not. Who knows? Who knows? Neither of those, unless that leg wasn't making contact, that might not be our issue. Let's see though. Has it cured it?
Okay, alright. Do you make AI conversations?
No, not any difference whatsoever. So it's not those. It wasn't those. So let's go back to our schematic again and let's just have a quick look at those two layouts. So C16, I think we said, and C18, those two. C16 is there, C18 is there. We need to check D3 and D4 as well. So I think we'll check D3 and D4 next. Let's just catch up on my chat. Let's see what the latest is. The mic commute, yeah. New OLED iPad Pros. I'd love one, but they are crazy money, aren't they? I've got the old older style one as well, Bob. iPad Pro, which I use all the time. I mean, Mrs. Cruncher bought me a MacBook Pro for Christmas, and I tend to use the iPad more. So I'm just trying to catch up. Sunny with that. Anyone like Taylor Swift? I can't say I'm a massive fan, to be fair, Jess, but I don't mind her stuff. Not someone I listen to, really. File browser, your best C16, you reckon? Yeah. Hi Joe, how are you? I reckon C16, but it could, I mean, it is in this circuit. It could be D3 or D4, but that would certainly mess it up. So would C18. So C16 and C18, but let's just have a quick look at those diodes a minute. So let's find out where D3 and D4 are. So D3 is there and D4 is up there, so that either side of the discriminator can. The problem with these is you can't get your probes in here to test them. Right, so I think what we're going to need to do is take those two caps out first. They're both 10 microfarads. Let me just mark the negative positions on the board. So that's a negative, and that's a negative in there. Fire up the desoldering tool again. Certainly you can see that those caps did need doing. So it looks like once they're cracked and the damp gets in, then you're in all sorts of trouble. Hang on, was that one on before? Let me just double check that that green one was on before. Let me just double check that while it's warming up again. Sounds shockingly bad, doesn't it? It is bad on FM. But it's in this module. It is in the module. So we'll get the ESR meter and we'll do these as we take them out one at a time so we can see if one of these actually is the issue. Yeah, that's the two I've just done, Gerard. Just changed those. That's the two ones I've done here. You can't quite see it. The two ready coloured ones, brick coloured ones. That was both the cracked ones, and if you notice, these have both got the ends cracked off of them. So that's the ones that I've just changed. I don't think there's any more cracked. But they haven't made it any worse and they haven't made it any better either. Well, let's get these two out then. I believe it's that one. And that one. Right, let's get that one out first. So this is C18. So this is in the FM output of the module. So it's 10 microfarads at 16 volts. So start your guessing now. Eyes down, looking. 50. I do like a drop of ELO, I must admit, Daniel. And welcome, Daniel. If I didn't say welcome earlier, mate. Dave's off. David. Nah, cheers, Dave. Thanks for dropping in, mate. Always good to see you. Keep up the good work with the videos. I've not caught up. I've got a couple of yours still to watch, which is a bit shocking. I need to catch up and get them done. Right, how are we doing on guessing here? You keep guessing them while I go and grab some more capacitors to put in. So where's my standard stock? There we go. That's the... Ow! Oh, stuck that in my finger then. They're all 10 at 16s. Whew. I think the other ones are 2.5. I think I put 2.2 or 3.3 back in there. Yeah, C19. There's 2.2. That's the AFC cap. Definitely won't get those mixed up. So 10 microfarads at 16 volts. So you have a guess at that while I've just popped this new one in. He's in. Right. What have we got then? Are we still going? Paddy's in. Hi, Paddy. Get my thing set at 360 as well. Knock that back down to 350. So we all reckon really high. Aaron's gone for 50 microfarads. 12, 13, 12. Oh, we're dropping down now, but... $12, 30. Aaron, you're having a double guess, are you? Oh dear. Hey, Christoph, how you doing, mate? Right, let's do it. Is this the one? No, it's not. 13.35. It's gone high, but it's not high enough, and it's got low ESR, so that one definitely isn't causing the problem. So we had FM at 13. I think it's FM has got that. Well done, Mr. FM. 0.35 out. You've got to try harder next time. A second 16. Yeah. Hi, Mike Cass. How are you? Right. Let's see if that's made any difference. I think we know the answer, though. Not that one. Okay. Let's go for everyone's favourite then, which is C16. I've still got a feeling it could be one of those diodes, you know. So, as we said, C16 is this one here. So this is our FM discriminator can, T10. We've got our two discriminator diodes, and we've got C16 right across it. So if that one's gone, that'll totally mess this section up. So we're hoping for C16 to be the cause. And that is this one here. So that's the next one to get out. So let's see if I can find it on the back of the board. It's across there, so that one. And that one. Right, another 10 microfarads then at 16 volts. Is this the one? It's got no signs of leakage on it. Eyes down looking then. Let me pop another one in. 10 at 16. And these are all Phillips caps, the old blue coated ones. Going to put those in there so as they stay all together. So you have a guess at that while I stick this one in. Not a lot of solder on that joint next to it. Let me just do that one as well. Looked like a dry joint that did. Was on a resistor, not the diode, but the diode is in there. So if this still doesn't work, I'm going to whip the diodes out, you know. I've gone and knocked a couple of my probes off now, so the last one is the red and black. Oh, it's got to be the green. Right, how are we doing? Thanks, Mike. That's a capacitor bingo appreciation club. $20.14.6, 2013. 19, 13 again for FM. Faulty, 16. 3, you never know, Bob. You never know, it could have gone low. Resistor bingo. That means I've got to pull loads of resistors then. So some sets do warrant pulling all the resistors. Some of those hacker boards certainly do. Buffering, it's looking good for me. What's the dry joint connected to the discriminator cap to the resistor in series with it? So let's have a look. So the dry joint was on The dry joint, I believe, let me just double check this, was on R18, and this one here. So if we look at R18 on the schematic, yes it is, so that could have been a problem as well, couldn't it? R18 is just there. It was dry. I wouldn't say it was moving, it just looked very dull as if it had no solder. But then saying that, I could have sucked the solder off of it when I did the one beside it. So I'm not overly thinking that that is an issue. Diode bingo. Ben, how you doing, Ben? I don't know if I said hello, mate. Apologies. Is Sandra in? I miss Sandra as well, or is she out and about doing some weeding, I bet? Right, let's push the button then. Is this the culprit? No, it's not. 13.04. It's not the problem. So we're going to have a bit of a draw here because we got two 13s, I think. We got FM saying 13 and we got Gavin saying 13. Anyone else with a 13? I think that was Gavin. Didn't we have someone say 14.6? So we got a draw there, Gavin and FM. So yeah, that's not the problem, but we will double check. We will power it back up again just to make sure. No, shockingly bad. I mean, it's not distorted enough for a diode to have completely gone, I don't think, but I'm not sure. I need to do this other one, which is the AFC. Now, whether that would affect just FM or... Of course it would, wouldn't it? But AFC does seem to be working. So let's do the AFC diode. Sandra's here, but away from the keyboard, no worries. Let's do C19 because that is the AFC, so that again affects FM. Look, see, I'm thinking that I had it in my head that was AGC, but it's not. It's AFC. So C19 could also be an issue, and that's the little 2.2 down here. So we're looking at 2.2 next then, people. So negative is to the front. .2 was actually 2.5. Again, no obvious signs of leaking. Let's hook her up then. 2.5. Get this thing off my head. You're recapping a cassette recorder, so you're doing your own private capacitor bingo at the moment. Oh, there is dozens and dozens in a cassette recorder. Mac Vision, how you doing, mate? Yeah, they're usually good, Ben, or they're really bad. Everyone reckons it's going to be pretty close by the looks of it. Are we all done? Pi. How many decimal points is that pi to as well? It's very flash. Right, here we go then. Oh! Oh! Well, we've got a cap that's 2.76, but we have got a pretty high ESR. Now, how are we gonna compare that? I mean, we can compare it to a new one. So we've got an ESR of 4 on this one, which could be a problem. Let me find another. Let's get one of these. 2.2. So bear in mind that's an ESR of 4. Let's try one of these I've just put in. 2.4, so lower values tend to be higher ESR, so yeah, it ain't great, but again, I think that might not be our problem. Who had 2.4 then? Ben had 2.44. That's got to be Ben, isn't it? Was it Bob? That was Bob, was it? I'm not going up high enough, am I? A 2.85 the other one was it? I can't remember now. Well done, Bob. So I don't think it's that one, but we'll test it. Let's try it. Has that cured it? No. No, that's not cured it. Just have a quick look over this modular. Just make sure we haven't got any other dry joints. I haven't really checked for that, have I? Tell you what. Gonna be in the market for some new glasses soon. Right, let's try the diodes next then. Let's have this one out first because I can see it, and the so the band is to there. I'm trying to see what they are now. These are AA119s. Right, okay. AA119. Let's put it on the component tester. See what it says. Diode junction, yes, it's a diode junction. Green is the anode, blue is the cathode. And it's got a forward voltage of 0.80, which is about right for a germanium, isn't it, I believe. Let's pop that one back in. Which is going to be easier said than done, because that's a bit of a fiddle trying to get that in there. That's because I got it the wrong way around. Let's carefully solder that one back in. Let's get the other little monkey out. Which looks like it is there. Right. No, that one's okay. Not the diodes. See if I can squeeze that one back in there. That's a shame because I was hedging my bets on one of those diodes, but not to be. I'll tell you what, these are a pain in the neck to get in. Let's use the forceps. We're running out of options, people. I'll get the other two caps done. Then maybe we've got to look at the transistors. Yes. Let's get the other two caps done then. Negative is there. And this one, the negative is there. Make sure these are definitely desoldered because one of those still seems pretty tight. That one's still pretty tight. Ow, yeah, that is the right one. I was beginning to doubt whether that was the right one though, but yeah, that was definitely warm enough to be the right one, Graham. And I just touched it again. Right, both 10 at 16 then, people, so get your 10 at 16 heads on and see where we go. This could be a problem, but I don't know. I think we've got a bit of a job on our hands if we're going to fix this module. No component detected because I haven't got anything connected to you. Right, what do you reckon to these then? 10 at 16s. Oh. that off. Okay, a bit warm. It is a bit warm. Should be lower than 0.8 for GE. Okay, well we can let me just confirm that then, because I have got here some AA 1.9s. So let's see. 119s even. Let's see what these read before we do the 10s. .79. So yeah, it is right. 0.79. If we try a different one, say, what have we got here? Let's try all sorts in here. I don't know which ones are which. Let's try this one, for example. This is going to be an OA90, I think, or OA91. The 0.6. So yeah, I don't. This is measuring forward voltage, not voltage drop, really, isn't it? Right, let's get back to the other two caps. You know, these could upset the circuit. They could mess with the frequency, I suppose. 10 at 16. Have you had a guess? Hi, Chris A. A bit high. I think if we test them with a normal multimeter rather than, I put a component tester on it there. If I test them with a normal multimeter, look, let's put your minds at rest, because I think it's just the fact that we've got so if I go to diode mode on this, it would go across the germanium. Nothing that way. 0.3, okay, so it's just the tester that I'm using it on. It's just because I use the component tester rather than the multimeter. And we could check across those, I suppose. Let's see, one was there and one was there. It says 0.4 that way, but then they've got other stuff in circuit. Yeah, they're measuring 0.4 in circuit, but they have got other stuff attached to them. Right. 10 at 16. $13.22. Danish is at 13.5. 13. I'll let you decide that one. You have to do the maths. I think 13 is closer than 13 point whatever it was, I'm not sure. And the other one? 11. So none of those were bad. We'll try it again just for good measure, but doesn't look like it. Now, as an example, now you can hear I've got, if I switch to AM, oh, hang on. Hang on. It's not going to work because my wires come off. In fact, 2 of my wires have come off. Let's try that again. So you can tell the difference in volume.
So we were tasked with finding a mark. We basically just wanted the first person to find it.
VHF, long wave. So virtually no sensitivity on VHF whatsoever, and distorted. So where else do we go? What else do we look at? So we're going to look at the circuit, see what's unique to FM on this circuit. Okay, so we know that FM goes through the bottom here. Now C3, where is C3? That's this one here with a little bit of tubing around it. 27 picofarads. Unlikely. Just caught that in time. Just had a sneeze. C5 we've done, C6, C4 we've done, D1. What is D1 doing? What is D1 doing, people? Do we know what D1 is doing? So we're coming in at pin 17. We're coming in at pin 17, which appears to feed AM, not FM. That's coming off, coming across in, that's linking onto the power rail, coming down and into this one, which does feed into here. We can put the meter across it, but it's unlikely that D1 would be causing us any problems. It's, so we've got C10, which is acting, and C11. C10 and C11 act on this transistor. C8 is another one of those little tiny picofarad ones. Might be an issue, but I've not really ever needed to do much with those little picofarad ones. C7 we've done. Was it C6 and C7 we've done, haven't we? I think. I know, C5 and C6. Anybody else got any suggestions? Because I'm going to have to go and have another pee. I can't believe it. I'm peeing for England at the moment. Let's have a list of components that we want to pull out for a look. I mean, it could be a dodgy IF can, couldn't it? We could have an open circuit IF can that might just about pass it, but not very well. Right. Let's have a look at the verdict then. Transistors, Derek's saying. Worth checking the transistors. Yeah, I totally agree. Maddie. Hey, Maddie's gone out for a walk. Yeah, we're still thinking potentially transistors. You're welcome, Bob. Transistors, transistors, transistors. Transistors, transistors. I don't think it's misaligned, Gio, no, because I have tweaked the cans just to double check that. Hey, Rob's back in. No, it's not working yet, Rob. In fact, I'm feeling a bit old and a little bit peculiar at the moment. I'm feeling a bit old and a bit peculiar. So I'm going to have to pop in something old and peculiar, aren't I? I'm going to have one. It's going to be a two beer stream at least, as a minimum. And if I'm really, really hacked off, I've got some strong stuff down there. I've got a drop of the champion at 8.4%. This is about 5% in it. Oh, peculiar. Oh, 5.6. Stronger than I thought. Still next door, driving in stakes into vampires. Can you hear that? I don't know what the hell's going on. Obviously building something. Definitely sounds like they're driving something into the ground. If it was winter, I'd say they were chopping wood. Anyway, cheers, people. Thanks for the super chat, Rob. Hope you had a good time, mate. You can't find any of that stateside either. Never mind. Speckled hen. Oh, you old crafty hen, yeah, 6.5, nice. No, it doesn't. It's the same as it was in the set, Rob. So definitely the fault is in the module, not anywhere else on the radio. We think it could be a transistor. Now, these are AF125s, and I've got to try and remember the pinouts on these. I'm going to try and remember the pinouts on them. I did have a little bit of paper with them all written on, and it all fell apart. And I need to write another little bit of paper. So let's AF125 pin out. PON pin out. AF125 pin out. That's a nice little one to print, that is. There you go. If you save your screens now, that gives you all the pinouts. I take it that's viewed from below. See, I always thought the little tab was the emitter on these, but it's not. It looks like it's the nearest the base. It's in between the base and the shield. Yeah. Handy little thing to have. That's from the vintageradio.com. Look. Catch you soon, Jer. You have to dial back in. Oh, a what out? A porn out? Did you say, Bob? Oh, a pong out. A pong out. No, pin out. A pin out, mate. Let's go and get that from the. Then the plan is to I think I can just about read that on A4. I think that's big enough. So now we need to work out which pin is which, and this is really difficult because they've got very short legs on these. So that is going to be the shield. Yeah, this is going to be mega hard. Because there's no room to get in there and draw. How are you going to do this then, Graham? This is going to be very difficult, people. I'm just going to have to do them one at a time. I'm going to just mark where the little peg is. With a little, can I do that? A little dot on the board? It would if this pen was any good. So if I mark where the little peg is on the board, can't get into that one, and I can't get into that one. That's great, isn't it? We certainly can this first one anyway. Let's get this one out first then. Right, again, we've got to be really careful of the tracks. It's a bit of a pain this, I'm going to do this every time, but you can't just wiggle them about and get them out. You need to make sure they're broken away from the track before you have a go at them. See, that one's still well held on there. Okay, so I mean, once I've got it off, I might be able to mark the board. So where's my bit of paper? I take it these are viewed from the underside, I hope they are. So shield and base. Oh, see, that's sneaky because that one sneaks right behind. So the front one is the base, and the back one is the shield because that sneaks in behind. Base, shield, and what's the one down there? So that's the base. This pen does not write. I've got another one here somewhere. Base, that's the shield. Shield. So where are we? Base, shield. So directly behind the shield is the collector. So that is the one over to the right. That's the collector. And that's got to be the emitter. Right. What are we looking for? We're looking for low gain. Rob's member for 17 months, Rob. Well done, mate. Thank you. Rob's radio channel just became a sponsor. Were transistors ever replaced before? Maybe one the wrong way round. Photo time. Yeah, let's try the transistor first. Let's see if we got a dodgy one. So we think that's the shield. HFE of 153, there's nothing wrong with that one. Low leakage, that ain't a problem. I mean, are you saying they've been put in wrong by the factory? You're thinking maybe. Well, that's an AF124 there. So let's just double check it then, I suppose. The base is going to that, transist that there. Base is going to that resistor and that resistor. Rolf, how you doing, mate? So which one are we on? We're on VT1. So it's going to R1, R2, the base. R1 and R2, yeah, that's definitely the base. So the emitter's going to R3. Which is this one at the back by the pot. R3 is there. What's that track there? The emitter and base are the right way round for sure. Let's have a look at where the collector goes to R4. Collector goes to R4, which is this one in here. Yeah, it's definitely the right way round, and we've got a good transistor. So that one's going back in. I mean, if we've got an HFE of like lower than, say, 50, then we've got problems. We should be higher than that. Right, that basically says VT1 is good. Now, where's this one going then? So we got our blob is there this time. Is that a decent pen? Problem is, if you leave the lids off the things, they go dry anyway. So there's a dot. I think that's the base there. Base. I think that's the shield back there. Right, let's get the second one out. Which I think is these four here. Alright, so that was that way. So that's base and emitter there. Base emitter, connector shield. Let me double check that. Got to be so careful with these. A number of these that I've got wrong in the past. It's very easily done, believe me, and I've done a lot of them. So base emitter. Base emitter. Collector. Well, this pen situation is a pain. Collector shield. Right, let's try this one. This is another AF124. I thought they were 125s, to be honest. So look, that's the, yeah, that's a collector. It's a long time since I've put any AF125s or anything in anything. I've been zapping them recently just to save costs for people, really. Right, let's see what screen we're on. Yeah, we're on the right one. So let's have a look at this one then. (137). Again, a good transistor. Low leakage. A good transistor. Very similar HFE to the last one. So let's check the pin out on it. So according to that, the emitter goes to this front one here. So let me have a look. Is that the one? Hang on. So it goes to R8. Emitter R8, yeah, the emitter's correct. The base goes to T3, which is that can. There. So the base we said was that one. Yeah. And it looks like the collector goes to a resistor down there. Which is behind that cap. It's R9 by the looks of it. Just let me double check that. Yeah, collector goes to R9. Yeah, that one is in the right way around as well. I didn't expect it not to be fair, but you know, let's do it properly, just in case. It's a long shot, but you never know. Solder that one back in. Right, the last one then. It's over here. So this one, I don't think I'm going to get a mark in there. No. So basically the little cap is facing these two transformers, so that one's in there, so let me just desolder that one. I think that's it. Just noticed something there, and it might have just been me blobbing a bit of solder, but there's like a little test capacitor there, and there's a blob of solder was on that, but again, ow, it's hot. Might be meaningless. But anything's worth a try. So what have we got now? Oh, that way around. So that's base. Base collector. Shield emitter. So base collector, shield emitter. Base. I'll tell you what's useless, a pencil would be better, wouldn't it? Yeah. Right, let's try this one. Is it the very last one that's the problem? .1. Yeah, that's no problems with that one either. Whew. We're definitely running out of ideas now. I better check this, I suppose, to pin out. Base goes to that there. R15. Hang on, R15. Well, according to that, that's not right. R15. According to this, R15 should be on the collector. On the base should be T6. T6 should be on the base. Where's T6? T6 should be on the base, which is that one. T6. T6 is on A. Oh, hang on. No, it's me. It's me. So it's that way round. So it's not the base. That's the collector at the top going to there. Collector going to R15. Yeah. Okay, so R14 is the emitter. I'm talking to myself here, but I'm sure you get the gist of what I'm doing. I'm just double checking that this is right. R14 and C10 is the emitter. Where's R14 then? That's right over there, to the other side of that one. R14. Yeah, that is, yeah, okay. Yeah, just me writing them down wrong. No surprise there. How the hell am I going to get that back in there? Right, let's get that back in. Okay. I'm pretty sure that that eliminates the transistors, don't you? Oh, I'm hot now. Should last for a long time, Tim. Well done, Rolf. Thanks, Aaron. Just catching up. Engineering bricks, yeah, I've done a few boiler hose through engineering bricks. When your felt tip pens dry out, can you take the back lid off? Yeah, I can. These are Sharpies, so they're normally pretty good, to be fair. They're Sharpie permanent markers, but they're ultra fine point. But yeah, I assume the back comes off. Why, are you thinking of dropping some ink in the back, are you? These are very good. I mean, I do get through them, but the problem is I keep leaving the tops off of them. Well, I haven't done anything, but let's just try it again, just in case maybe that there was a dodgy solder joint, or perhaps I've dislodged something. No, still deaf as a post. Right, we've got to start looking further now, haven't we? Let's just check that diode there a minute while I've got the meter. As I say, I don't think that's got anything to do with it, but you never know. So another germanium, so we should be looking for around about 0.3, 0.4 on this one. .4, that one's okay. That's the only other diode in there, so that's all the semiconductors tested then, really. Oh, actually no, there's one other diode there. Let's just check that one. Oh, hello. Have we got it? Ooh! Oh, is there something across it? I don't know, but let's take it out and have a look. Let's just see which way round it is. So it's got the leg to the back. So it's the leg up nearest the edge of the board. It's shown as a short in circuit. Let's pop him out and see what he says. A shorted diode? Nothing that way. No. Just something in that circuit is shorting that diode. Let's just double check the schematic a minute. So that is, what have I just pulled? Pulled that one there, which is up there. That is D2. So what is D2 across that's shorting it? So what is a D2 across that's showing it as a short then? There's D2, so if I go from there to there, it's showing a short. So we've got a short there, but that's not coming back that way, is it? I don't think. No. It's coming back that way. Going back up there. No, what would be cool, given that as a short then? What would be shorted across there? C13 maybe? Anybody got any ideas? D2 showing a short in circuit? Let me just check the circuit a minute. D2's out. Let me just probe that across. Nothing that way. No, it's open circuit now. But with it in circuit, it was showing a short. Strange. Hang on. I just knocked that one off the chart. Okay. Pass. Oh no, it's on the table here. Let's catch up a minute. Yes, yeah, I remember that, Timothy. Yeah, that was a hacker, wasn't it? Transformers, Anthony's saying, it's been damp. Oh, take them out, add a few drops of water, okay. Replace the module. Ah, we haven't got another module to replace it with. Catch you soon, FM. Cheers, mate. What's a mogul? The mogul. A module, you mean, Rob? Mogul. Take C13 out and check again. D2 marginal. Check where it was. Yeah, just check that there. I reckon it's not short now. Yeah, I haven't. I'd need to recap another module to do that. Not to say that we couldn't do that. Right, let me just double check that again then. So if I go across that one there, 250 ohms. I held wrong one there. 4.8k, and the other way 4 ohms, which is about the resistance of these leads. Yeah, so it's a short just one way. Which ones? Let's have a look at the other bits in this area then. So C13 could potentially be a problem. I'll tell you what, it's hot in here. My back's starting to ache as well, so we won't be going on much longer, people. C13. Go on for a little bit yet though. C13, where's that to then? C15. So C13 is that little one there. Let's pop that one out. Let's see if that removes that short then back the other way. $4K. 4K, yeah, that does remove that short, so let's have a look at this one then. Let's stick this one on the capacitor tester. What we'll do first is we'll just calibrate the leads on this. So, C13 is this one here. Look, that's the one I've just pulled out. And it is that one there. I mean, it's in the AM section, really, so I think we're barking up the wrong tree here, totally. You know, we need to be coming back through here, really, but it does seem strange, doesn't it? So we'll just check C13, and what is C13? Going to this 10NF ceramic plate. So let's just do the probe compensation on this one a minute. I'm just going to quickly do the probe compensation so we get a decent yeah, D2's okay, Aaron, it measures fine. But it's on the AM side, so I'm not convinced that this is, we're definitely going on a red herring here. Just reading 12 NF, and it should be 10, I think, so it's 2 NF over. It's gone a little bit high, but not enough to cause us any issues, I don't think. I didn't do the probe compensation properly either there. I could put a 10 NF back in there just to prove it, I suppose, couldn't I? And then I haven't got one the same type. Got these weird little polystyrene thingies. No. I haven't got another one of those, so I'm going to stick that one back in. As I say, it's in the AM section. It's absolutely nothing to do with FM, so that's going back in. Definitely barking up the wrong tree there, really. But, you know, it's worth looking at. I was just looking for a short, you know, but that cap's not short. Right, what else can we think? You know, I'll tell you something else that's gone wrong in the past. It's these blobby caps. And I mean these orange topped ones here. C15 and C14. I've had those go bad before. C15 and 14, and they're in this area. Ceramic bead, 330 picofarads. Let's pop a couple of those and have a look then. It's unusual, 330 picofarads, probably something I won't have. But I have changed them before. It didn't cure the problem, mind you, but I have changed them before. Cool him down a minute. So a bit of isopropyl, cool him down a bit. Very odd shaped capacitor. So 330 picofarads. He's measuring 300 picofarads, so he's 30 picofarads off, but that's not massive, is it? I'm just going to push him back in there for a minute. I'm not going to solder him back yet. Let's see what this other one says, because they should be balanced, I'd have thought, those two. I think it's them two there. Just give me a bit of a cool down treatment. We're fast going through all these things. I mean, yeah, so 305 picofarads, so they're 30 picofarads out. I mean, I don't even think I've got any 330 picofarads here. It's an unusual size, isn't it? .33 NF. I've got nothing like that. No, 0.33 NF. Is that likely to cause us a problem? I don't know. CO2 exits. I see what you're saying, Aaron. Yeah, I mean, I'll have a look, see if I've got any 330s, but it's unlikely. It's a funny size, isn't it? I do have some funny stuff here though that I've bought from clearance stuff, but 330 picofarads, 0.33 NF. Oh, I have got some 330 picofarads. If you remember, quite some time ago, Paul, Mr. Cody, very kindly gave me some capacitors and suggested that I buy this little kit because it's got some useful values in it, and I bought one, and sure enough, 330 picofarads. It's 3 kilovolts, but you know, what the hell? What's a kilovolt between friends? A capacitor is a capacitor, really, I suppose. It's not going to affect this circuit, I would have thought. So we could put a couple of those in, see if it affects it. You just never know, do you? Now we might see if we can match these. So let's try them both. Let me just do that exact, let me just do that probe compensation again, because I didn't do that right just now. I'm sure I didn't. Short the probes and press enter. I'll have some old peculiar while I'm thinking about that. Open the probes and press enter. It might be that this just needed calibrating and this is going to measure exactly 330 now. Right, probe properties stored. Let's just retest this cap then. He's cooled down as well now. So he's reading actually lower now. He's reading 293 now. Let's try one of our new ones. try this one. .336. Oh, here we go. So we got 336, which is closer. So that's the closest so far. .336. They're identical. Oh, 344. It's just a manufacturing tolerances. It's rubbish on some. 331, that's pretty good. That's the best so far. If we can find another 331, we are good to go. 291. I'm sure this isn't that critical, but it is in the discriminator circuit, so maybe it is 319. .305. There's only two left. .338. And the last one, is it Sod's Law? And this one's exactly the same as the 331. What do you think? 320. No. So those two there are matched. All the rest are thereabouts, but not. They're certainly higher than the ones that are in there. All right, let's pop those two weirdos out and put a couple normal looking caps in. It's good fun experimenting with this stuff, isn't it, really? But I think we're in the right area of the board anyway, but still don't know whether we're anywhere nearer. All I know is the problem is in the module. Put a bit of solder on that because I've sucked that off. Right, that's those two gone. Let's try that for size. See you like that, Mr. R707.
Watching the concert through someone else's phone. Yeah. I'm like, oh, my 5 foot 6 is hard to see sometimes. Yeah, just have its uses. I do get it though.
Something really wrong with this, because if I get it on the station, then pop the AFC in, it's just that there's something wrong in that AFC side of it for sure, and it's somehow. Thank you, Rob. What have you been? Caps lock, Rob. Caps lock, big mistake. Aaron's done the same. Yeah, but what? What am I on to? Where do we go next? It's got to be in this area. It's got to be in this area. Can we mark this up? Can we edit with that? Edit with Acrobat. No, it's not editable. Just wanted to see if I could mark stuff. So we've done C16, C15 and C14 we've just done. We've checked D4, D3, we've checked all of that. R18 we haven't checked, R21 we haven't checked, R20, R19 we haven't checked. So there's resistors in there, and this AFC is not working. Now C19, that's changed. That's our positive rail. So we've got 1, 2, 3, 4, maybe 5 resistors in that area. What's the likelihood of one of those resistors going though? These are modern resistors and not the carbon types. They're the metal film, and I'm not convinced that they would be an issue, but you never know. You just never know. Yeah. I'm head scratching now. We're down to resistors. I mean, we can go further back into the circuit. So we check that. We've got resistors in around there, but then they're common to AM as well, aren't they? But I suppose they could be bleeding off frequencies. Well, let me do any editing. No, let me. No, it's not editable. I'd have to copy it to a JPEG, screen grab it, and then I could highlight bits that we've changed. It's starting to get confusing. We checked C13 as well, didn't we? That was a little bit high, but not a problem. We checked D2. You know, my gut feeling is it's in this area here. You know, the IF seems okay because that's all working for AM. AM is no problem. AM shoots off at the top here. The only bit that's sort of like a bit quirky and unique to FM is this bit here. But there is something going on with the AFC, which again is all connected to this part of the circuit. Anybody got any ideas then? Are we down to just checking resistors now and the remaining caps, although we've changed some of these? Let me do a screen grab a minute and I'll so is it just print screen? Print screen. So I'll do a screen grab and I can just mark on it the bits that we've actually changed. Yeah, but they're hellish tiny, Anthony. Taking those apart would most likely break them. Now, I have got a box of modules, but they're all sort of spares modules. So I've got transformers. You know, I can check the resistances and compare boards. That's something I could try. Mike Blockley, how you doing, mate? Did you check leakage to the transistor cans? I didn't, but these are AF125s, Mick. They're not AF117s. I can power it up and see if there's any voltage on the cans. Have you ever known an AF125 to go short to the can, though? But it's a fair comment. I mean, anything's possible, isn't it? We're clutching at straws, shall I say, not grabbing at straws. I can see my Roberts modules box. It's got something rested. Oh, that's my Amiga 500 plus board. Brand new. Oh. So I have Roberts. And this is not modules that belong to Robert. These are from Robert's radios. I just thought I'd get that. Aaron's off. You're going to miss all this loveliness, Aaron. Oh, look. Touch them. Modules. Even an R404 module. I've got an R404. Is it a 404? I've got one in for repair at the moment in the queue. So this is interesting. This has got LP1171, which I believe this is, and it's not the 1164. It's the 1171, isn't it? I'm not cracking that. Oh, it's the 1164. Okay. 1171, 1164. Bad AM. No, where is it? I think it's that one. So this one had bad AM, and I went mental on it and went through everything, changed everything, but could not get it to work. Refurb. FM poor, so that one's no good. No FM. That's the same one. What's the crack with that one then? Looks like I put new transistors in that one. The problem is these are all out of their out of their cases. What's this one here? I don't know what that is. Let's see what this one is a minute. No, that's one out of an AF. So it's got the extra IF can in it. That's an R600. That is. That's an AF1171. Sorry, LP1171. Just going to put that one back together and just put a note on it that it's an LP1171. Where's my decent pen? Come on, Graham, you're starting to get in the muddle now. FM4. So we got these two. Now, I don't know if either of these are any good, to be fair. In fact, they're probably almost definitely not any good because I've changed the transistors on them and they're still not working. So the likelihood is they're no good, but it's worth just seeing if FM works on one of these compared to that one. It might be that AM's no good on one of these, if you know what I mean. I hate these rubbish things. Gotta get myself something else sorted for these, you know. So if FM's good on one of these, all I'm thinking is I could change out the discriminator discriminator, can. It might be that AM's bad on one of these. There's only so long you've got to play with these before you've got to pull another module out of something else and swap it. And that's what's happened with these. I've just given up on them, really. Right, let's see if this one does anything then. Let's see. That is working fine on FM.
It's about to have its moment.
Long wave. Right, let me have a look a minute, see if this is working on AM. I'm going to stick a signal generator on because I've got so much stuff in here all interfering with the signal that it's impossible to get a station in here. Although long wave should be able to get radio 4 at a push. Should be right.
Michael Collins at the end of the affair.
That is working, that module.
Welcome to the show. Thank you so much for having me. You were born in Sligo, in Ireland, in 1950, and you grew up in...
Shortwave works on this set. Okay. Sorry, I'm zoomed right in, aren't I?
About strange men who would walk these places and ask you strange questions, like, what do you do?
As Owen begins to play.
Not talk dirty, baby.
Well, that module seems to be the dog's business, doesn't it? So it looks to me like I've refurbed that and not done anything with it. Why would I have done that? Strange. Right, let's just try this last one then. Then we can perhaps do some comparisons with the windings on each one, if you know what I mean. So let's connect this one up. Let's turn that off for a minute, that noisy old thing. There's lots of things in here that are interfering with AM, and AM is just non-existent here now, which is a real shame. We used to have some good channels. We used to have Radio Devon that we could use, which used to come in loud and clear on AM, but they got rid of that because it was too nice. Can't let's have nice stuff, can they? Yeah, they used to come in loud and strong here. That's one of these boards I spent a lot of time assing about with and gave up on it in the end. Right, so that's a good one. Let's see what this one sounds like. There's a bit of distortion in there again, I think. That's got the same problem with AFC not working.
Or shoot. Radio 1's live.
No, AFC's really bad on that one. That's no good. That module is kaput. Right, so that's a spares module. We still have the same FM problem on that. So maybe if we can solve the FM problem with this board, we can fix this board. I forgot how that all gets wired up now. Let's pop that light back on then. Yay! Thanks, Paul. Thank you, Paul. Much appreciated, mate. Thanks again, Mike Cass, for the tip. And they're just back and trying to pick up what's been going on. Has R15 been checked? R15, I'm not sure yet. Gerard, I'm a bit confused now. Worth checking the voltage of the AFC out with the AFC switched off. Bob was saying, is it worth checking the voltage of the AFC out with the AFC switched off? I remember the circuit, you might be able to do a sanity check, voltage divider across the discriminator cap. Wow. That's a good question. What did I do with this, by the way? Did I put GT322Bs in that one? Yeah, that one's actually got Russian transistors in that one. Says the Russians. I can't believe I've got to go to the toilet again. I have still got a waterworks issue, so I do tend to go a little bit more often than it should be. But I'll be back very shortly. Right, let's go. That's interesting what Bob has just said, actually, because it's given me another idea to sort of try and prove something. It means I've got to get my book out again and wire that back in. And then let me have a think. So this is R1. So let's wire this one back in again a minute. This is the one that I've redone. What have you known? Did you check leakage to the transistor cans? You've known leaky ones. There might be enough internal capacitor to attenuate the FM signal. Yeah, I hear you, Mick. I didn't test it. P counter. Oh dear. Yes, so what I'm thinking is to reconnect this and then disconnect the AFC line. I don't think that'll stop it working, will it? That is my second pint of beer, mind you, so it's a pee a pint, isn't it? Is that the rule? A pee a pint? And I've got my emergency champion down there. Right, let's just wire this back up again a minute. It is interesting messing about with this stuff because I would rather try and get to the bottom of something than just carry on and change it for the hell of it. Right, let's do this side first. So that's... So the green one is the AFC out. Purple is FM out. And black is the ground. So opposite this we've got red, yellow, green. Good old Frankie, he always helps us out, doesn't he? The ground has got a shorter lead, it needs to be longer. Then we've got purple. Let me skip one and red. Right, let's turn that back on again then. So it's a green one here, wasn't it? So let's have a look at the AFC voltage then. Oh, peculiar. Here we go. I want to touch a negative. Let's see this. This is 0.8 of a volt. Kills it dead touching it, so 0.7 with it disconnected, 0.8 with it connected. Meter seems to be loading it down for some reason. What if I go off the main ground there? Yeah, 0.8. Actually,
It's some Finland, Tineke Orchestra under Kevin on everything. We know you love that. It's in the Hall of Fame top 20. So it's nearly 5:30 on a Sunday, and that means it's time for my weekly classical A to Z, where I explain musical notes and notions. And we've arrived at the letter S today. I'm starting to run out of letters. Any suggestions for what I should run the alphabet? 6, 18, 12 to text.
It looks like AFC is
for scale. Now you might be thinking, Stephen, I know what a scale
changing
is,
with the station, isn't it?
A scale is not just a sequence. Right?
0.7 and then 0.05 of it switched out.
Pieces with prominent scale.
I don't know if we're going to gain anything by checking that. There is no adjustment procedure for them. You've just got to look at the circuit, really, I suppose. Actually, no, that one's there. I want it blue, purple, and green. Yeah. So let me think, it was .7 and 0.05. Depends on that. So let's connect it up to our working module. See what the difference is in the voltage. Oh, I hate these things. Cheap rubbish. There we go. Bet NASA don't have these problems, do they? What's going on here then? Red, miss, purple, ground, oh, purple, ground, I don't know that I had that module connected up right that time, you know. Red. Oh, yes, it is. Yellow. Ground. 3, 6, 3, 6. I'm getting myself confused now. Right, red, yellow, green. Black, purple, and the red and black. Right, okay. Let's see what the AFC voltage is measuring on this one then. Or a decent one. .28 of a volt. Let's turn AFC off. 0.9. 1 volt.
Would you be able to make that same film today, given the current politics around the issue of gender identity?
I don't think you would, actually, no. I really don't think you would. But does that matter? I think you make a different kind of movie, and I think, for one thing, the minute he walks into that bar, Stephen Ray walks into the bar, you know exactly what the nature
We've
of
got
the bar
minus voltage there.
Let's call this the usual. You do today.
Today,
So that's tuner station.
kind of a sleep walking into his heart, surrounded by transsexuals, not knowing that's what they were. You can't imagine that.
Let's
See her, didn't you? Listen, there's something I should tell you. She's swatted.
minus 1.4.
But the naivety is in keeping.
Yeah, I think so. Well, it absolutely was at the time, you know.
That's not giving me any clues at all. What is going on there? So that's AFC on, because just now I had more voltage than that there, didn't I? I suppose it depends where you are. 0.09.
Story.
AFC on, up the other end of the scale. Minus 0.3. Plus 0.3. Clearly that one is knackered as far as AFC goes, isn't it? But would that be the are we all with me, or are we going off on a tangent? We're on weather now. Let's yeah, all right, Mick. You're always with me. I just think we've got problems here. I think I need to check some continuity issues. Bob's there with me. I think we need to check the coils in this discriminator, maybe. Certainly check R23. R20, 21 and 23. R20, 21 and 23. I'll say 20, 21 and 23. Yeah, 20, 21 and 23. Pointless using this meter though, because if I go across the leads on this meter, no, you won't see me. If I go across the leads on this meter, 1.4 ohms, and I mean if I wiggle the leads, I've got problems with the leads here. They're all over the place, aren't they? Seem to have sort of corrected it there. Let's try R23 then first. R23. No, that's in this knackered one, isn't it? So R23 is that one between there and there. It's basically 100k R23, and it should be 100k R20, R21 then. So R20 is the next one up, which is there. It's reading 5.5k R20. R20 should be 5.6k, so pretty close. 21 is this one, so it's there to there. 5.4k. That's the same, isn't it? Yeah, so they're thereabouts. So really that's eliminated those. R18 we need to check. R18 should be 1k. Let me just find where R18, because that's the one that I think was had a bad solder joint, but I desoldered that, I reckon. I reckon that was just me. So that's in there. So that's there to there. .98 of a K. Yeah, see, the resistors are all measuring fine. The only other thing I can check is the continuity on the cans. Well, let's check. I'll take it that's the output coil there. Well, that's 0.0. That's a dead short there. I don't know how these cans are wired though. It might be that the windings, that might just be the earthing points. Four, 6. Short. Yeah. Short 0.46. Yeah, that's the same. Let's try the other side then. So they're joined together. So what's that there? It's got to be the other winding there. 0.38 on that one. 0.3, yeah, so that discriminator can appears to be the same, although God knows how many windings are on it. Yeah. 0.4, 0.2, 0.2. Yeah, those discriminator cans are identical. So I'm flummoxed as to what the problem is with that. Well, AFC voltages are different. My chair's just declined itself. I need a new gas shock thing for this. Let's catch up on my chat. Hey Rob, how you doing? Thank you, mate. Maybe someone may have twiddled with it. I don't think they have. I did have a go at a line in it. R15. What was the importance of R15? I haven't checked R15, Gerard. No, let me just see where R15 is then. Have I checked R15? R23? R15? No, I haven't checked R15. That's by VT3. Let's check R15. That's that little baby there. $118 ohms. What does it read on this one? 118 ohms, so it reads the same as that one, to be fair. I don't know what it should be on the system. R15. 120 ohms, yeah, that one's fine as well, Gerard. No worries, Ben. Checking IF is nearly always 10.7. It would be 10.7. Scientifically analyze one and do a PowerPoint. That would be good. Was C12 checked, Anthony? Let me see. C12. Where is C12? C13 we definitely did. C12. That's in between the two cans. C12. No, I haven't checked C12. can check it in circuit with this one, I think. C12. Where are you, C12? Is that you there? Is that you there, C12? No, we can't check it with that thing. Pretty sure it's there. There. See if we can check it in circuit. Either I'm in the wrong place, it's not liking that. It's all over the shop. Let's check this one. No, that was reading all over the shop as well. I'd have to pop that one out to check it. Check it. Well, what are we saying here? What are we saying here? Cheers, Derek. Have a good rest of your holiday, mate. A proper alignment without procedure might be difficult, though. Jet 10.7 at the front end to measure the voltage across the discriminator cap. Yes, he does. He does. You are right, and he's a very clever chap. And I couldn't get my head around it, to be honest, Ben. Diego Diaz, welcome, mate. I don't know what screen we're on. What are we on? Oh yeah, we're on my bench still. Yeah, welcome, Thiago. I don't know if that's how you pronounce it. Yeah, we're definitely not going to be doing that today. But I definitely agree, Bob. If you hold that thought, we'll have a look at that. Inject 10.7 megs at the front end. Measure the voltage across the discriminator cap. A discriminator cap being C16, I take it. Well, there's lots of caps in the discriminator. You mean C16 in the discriminator cap? Or, I mean, C15 and C14 are both in the discriminator. That's probably C16 you mean, is it? That a one? because this is the discriminator circuit here, and I've checked every part of this. Obviously I haven't checked that cap inside there, because I can't get inside these little tiny cans. All I could do would be to swap the can out, but in doing that you're heating up all these little tiny wires inside, and you could well just pop one off. They're horrible to work on. I can do it. I could take that out and put another one in. That's not a major issue, but yeah, so C16, is that the one we're talking about? Yeah, C16. Someone gave up on one, but that was where FM was working fine, but not AM. Yeah, I mean, 9 times out of 10 it's the transistors. I mean, I know Mick has suggested testing them for leakage. I'll say this one here, I've actually put the Russian GT322Vs in there, which appear to be working nice. So yeah. I don't know. I think what I'm going to do in the week is I'm going to get this under the microscope, and I'm going to go over all the tracks in the microscope. Now I know that we've got a known working board. I'm on the wrong camera. So yeah, what I'll do is I'll go over the tracks on this one, clean it all up, go over the tracks with a microscope and have a look very closely, just make sure we've got nothing broken, no dry joints. And then I'll just have to do continuity checks. These little transformers, ideally I want a layout on the back. I have got some close-up photos I've done in the past on the back of these, showing which terminals are which, you know, where you connect everything. I've still got those photos, so I could mark the rest of the bits on the back of the board, if you know what I mean. I'd have to blow it up huge to get the text in because it's so small. It's tiny, but it's doable. It is doable. Silver mica disease. I don't even know if there's silver mica caps in there. Yeah, using the scope to trace quality of signals it passes through various stages. I mean, what's the best option? Yeah, I've got a couple. That other one's definitely got the same issue, but that's got really distorted AM on that one as well. That one's nasty. That's nasty. I mean, the board itself is bowed. Oh dear. Yeah, that one's had it. But that one's just got bad FM. But AM seems good. That's good AM and FM. Excuse me. Oh, dear. Yeah, more investigation necessary. Silver mica. Cheers, Derek. It could be. The problem is, as I say, getting those little cans out, they could have silver mica problems. I mean, you don't know which one it is either. It could, you know, it could be any of the cans, couldn't it? But it does. There definitely seems to be something to do with AFC and the discriminator circuit, which is introducing distortion. Because I don't think you get distortion through the IF stage, really, do you? Unless it's distorted back further and it's amplifying it. But I mean, I'm convinced it's in this section. You know, we could try swapping T10 across with both of them. If I swap T10 from the good one into the bad one, and then it works. T10 being the discriminator can. T10, if I was to swap the good one into here, and then it worked, that would be fine. But I mean, in the past, I found that T8 and T10 are fairly interactive, but it doesn't seem to be on the one that's not working properly. But I could swap that whole can out. There's a lot of connections on that, isn't there? 1, 2, 3, 5 connections, yeah. So I can certainly pull C12 and test it. So yeah, still lots to do. And I was hoping that we would have got this radio back together today, look. How wrong you can be, isn't it? How wrong you can be. I really thought we'd have had this radio done and dusted and back together. There is something in there that's not right, but what it is, I do not know at the moment. Yeah, thanks, Bob. The back has been dodgy since February, so doesn't seem to be going away. You don't think it would be silver micros? It would be sound crackly if so. Yeah. Yeah, Thomas, that's a good idea. I've got some of the AA119s there. I could pop a couple of those in just to see. So there's still lots to do. So I think what I need to do, if we're going to carry on with this one next week, is I need to make a game plan rather than going back and forth over stuff. I need to get a diagram first, mark on it what components we've checked, check a few others. Maybe I'll do that off camera during the week if I get a chance. I keep saying in the week. I mean, I should have chance now, being that I'm still off work, but I've still got a lot of repairs to do. Title of that Simon Spires video, I'm not sure, Joe. You'll have to just go back over. He did do a little demo video for me on the sweep generator, because I've got a sweep generator up here, and he actually used exactly the same one. I did try it, but I just couldn't get it to do the same thing. That's it from me then, people, today. I mean, it's been interesting, that's what I'll say. We haven't really achieved a lot, apart from we've got further down the line. Somewhere we'll find it, potentially. It might take us another 30 streams yet to do the module. But we've got to do it. We've got to do it. So cheers, everybody, and thanks very much for the tips and the super chats today. And I'll catch you all next week, if not before. So bye for now.